Okay, so example 3. A drawer contains 3 red paper clips, 4 green, and 5 blue. 1 paper clip is taken from the drawer and then it is replaced. So since we are taking it out and then replacing it, is that independent or dependent? Independent. Because what I draw the first time, since I put it back, has nothing to do with what I draw the second time. Okay? So how many paper clips total do I have first? I have 3, 4, and 5, so that's 12 total. Now here's the actual problem. Another paper clip is taken from the drawer after you replace the first one. What is the probability that the first is red and the second is blue? So first we need to look at what's the probability that my first paper clip is going to be red. 3 out of 12. The word is and, so I'm going to multiply. What is the probability that the second one is going to be blue? Remember, I put the red one back. So how many total paper clips do I have in the drawer?
5.
Still 12, because I put it back. How many of them are blue? 5. Okay, so because they're independent, our denominators are the same, because we put it back. Reduce as much as you can. So that's going to be 3 goes into 12, 4 times. So that's going to give me 5 over 48. And that doesn't reduce anymore. Not bad? Okay. So same drawer paper clips. Example 4. 1 is taken from the drawer and not replaced, and then we draw a second one. So if I take 1 paper clip out and I keep it, are those events independent or dependent? Dependent. Okay, so they are dependent events. What is the probability that the first is red and the second is blue? So probability that the first one is going to be red is 3 over 12. The word is and, so we multiply. Now, I kept that red paper clip. So how many total paper clips do I have? 11. How many blue ones do I have?
5.
Still 5. So we have 3 over 12 times 5 over 11. 3 goes into 12 4 times, so that gives me 5 over 44. See the difference? Yeah? Okay. It is still awkward numbers. You're not going to get away from that in this unit, unfortunately. Okay, so now I have coins. 10 of them. 3 dimes, 5 quarters, and 2 pennies. So that is 10 total, right? It says that. Okay, part A. A coin is selected and replaced 3 times. Independent or dependent? Independent. Find the probability that all 3 are dimes. Okay, so this is kind of like the CDs question. All 3 coins are dimes. So my first one is a dime, and my second one is a dime, and my third one is a dime. Are those and statements or statements? And. So what am I going to be doing? Multiplying. So what's the probability that my first one is a dime? 3 out of 10. Times. I put it back, so what's the probability that the next one is a dime? 3 out of 10. And then I put it back, so what's the probability that the last one is a 10? 3 out of 10. That's going to give me 3 times 3 times 3, 27 over 1,000. Not very good, great odds. You can't reduce it, so you're done. I know. So let's... we still have the same amount of coins, and we're still doing the same thing, except this time we are not replacing them. So are those independent or dependent? Dependent. Find the probability that all 3 are dimes. So these are still and statements, so we are still multiplying. So what's the probability that the first one I pull is a dime? 3 out of 10. But I don't put it back, so what's the probability that my second is a dime? 2 out of 9, and I don't put that one back. So the last one would be a dime is 1 out of 8. Now, I suggest that you reduce this as much as possible. 3 goes into 9 3 times, and 2 goes into 8 4 times. So that's going to be 1 on top over
30.
120.
Smith, the only thing I remember was
Okay, this is a chart about college majors. We have a student named John. John is trying to decide between 2 majors, architecture or engineering. If he chooses architecture, there are 2 choices, residential architecture or commercial architecture. If he chooses engineering, there are 2 choices, mechanical engineering or electrical engineering. I want to find out I give you the probabilities that he's going to choose each of the sub-majors, but not of the 2 main majors, architecture or engineering, okay? Basically, the way that this chart works, if he chooses architecture and then chooses commercial, the probability that he chooses architecture times the probability that he chooses commercial will equal the probability that both of them will happen at the same time, correct?
Correct.
Probability of architecture and commercial. Okay? It's just like saying the probability of A and B happening is A times B. That's what we've been doing this whole time. The only difference here is that I give you a little bit of different information. So look at the information that I'm giving you. The probability of choosing architecture and commercial is 72%, so 0.72. Where could I plug that in? Do I plug it in here, here, or in the last one? The last one, that's what it is. So it's going to be 0.72. That's what I plug in here. Do you know between the probability of choosing architecture and the probability of choosing commercial, do you know one of those? Commercial is what? 90%, so 0.9. So we're just looking for the probability of choosing architecture. How can I get that probability by itself? Divide by 0.9, because it's multiplication. It says that this one is 90, and the probability that he's going to go this route is 72%, but not architecture in general. So what's the probability that he's going to choose architecture in general?
8 over 8.
It comes out to 0.8, which is 80%. So the probability that he's going to choose architecture is 80%. What's the probability that he's going to choose engineering? 20%. Okay? So first we have to look at the probability he's going to choose either architecture or engineering. That's what we were trying to figure out. If he chooses architecture, then he has to choose between residential and commercial. And there's the percentages there. Does that make sense? Okay? These charts will always be given to you. They are a little confusing. You just need to practice with them, but the steps are always the same. Example 7. This chart will be given to you. Now, the employees at this distribution company are listed. I give you all the men and all of the women. Some are college grads and some are not. I want to know, what is the probability if you randomly pick an employee that it will be a female, and here's the important part, given that you pick a college graduate? What does that given mean? It means I already know that I'm picking from the college graduates. So do I have to look at all of the columns here? What's the only column I have to look at? This one right here. How many college graduates total are there? 19. So out of 19, how many are women? So what's the probability that you will pick a woman given that you know she's a college graduate? 12 out of 19. Common sense. Okay? There is a formula for this. It's called conditional probability. On these types of problems, you will be given a chart. So you really don't use the formula all that much. In your homework, there will be problems like example 8. Basically, you take what's given to you and plug it into this formula to solve for the rest of them, just like we did in the previous problem. Okay? If the chart is given to you, go ahead and use your common sense. Okay?